Namaste, welcome back to my channel Qubit Educational Services. In this video we are going to solve the 1 mark questions from GATE XE 2007, which is the oldest available paper right now. Okay, and you will find that in this particular question paper there were 24 questions, out of which 6 were of 1 mark and the remaining 18 questions were of 2 marks. So 42 marks were from engineering mathematics. Okay, so in the recent years it has dropped to almost a third of what it used to be, because now the questions are asked and the weightage is about 14 to 15 marks. Okay, so you will also find a lot of variety, especially in the years 2007, 8 and 9. Okay, alright. So we will start with our first question, which is based on linear algebra, specifically eigenvalues. So let M be the matrix 1 1 1 0 1 1 0 0 1. Then the maximum number of linearly independent eigenvectors of M is 0, 1, 2 and 3. Now to solve this problem, we first note that the matrix M that we have is an upper triangular matrix, right? Because all elements below the diagonal are 0, and for such matrices, be it lower triangular, upper triangular or a diagonal, the eigenvalues are equal to the diagonal elements, which in this case are 1, 1 and 1. Okay, so only one eigenvalue is there and that is equal to 1, but it is not an identity matrix. Okay. Now, in order to determine the eigenvector or vectors corresponding to the eigenvalue 1, we will use the fundamental equation, which is A minus lambda I into X is equal to null matrix, okay, or null vector in this case. So X is the unknown eigenvector here, and we know that this eigenvector must have dimensions 3 by 1, okay, because M is of order 3. Okay. So what we are required to do is we are required to subtract the eigenvalue 1 from the diagonal elements, correct? So we will get 0 0 0 along the diagonal and 1 1 and 1 here, and nothing will happen to the remaining zeros below the diagonal. Okay. Now as we expect, by definition determinant of A minus lambda I is equal to 0, which means our system of equations must possess or will possess infinitely many solutions or non-trivial solutions. Okay, and as you can see, the third row has become 0, which implies that the rank of the coefficient matrix and that of the augmented matrix is 2, which is less than the number of unknowns, which is 3. Okay, alright. Now we will go to R2. So R2 will give us the equation 0x plus 0y plus z equal to 0, which implies that z is equal to 0. Correct, from the second row, and from the first row we have 0x plus y plus z equal to 0, but because z is 0, y is also equal to 0. Okay, so there is only one free variable here, so to speak, and that is equal to x, right? Because it is 0 into x, so x can have any value. But what they are asking us is, they are asking us to determine the maximum number of linearly independent eigenvectors. Correct, but what we have got here is we have got only one eigenvector, and all other eigenvectors are basically collinear with this, right? So they are obviously linearly dependent on this. So this particular matrix possesses only one linearly independent eigenvector. Of course, it possesses infinitely many eigenvectors. Let's say 2 0 0 is also an eigenvector, but it is not linearly independent of 1 0 0. Okay, so there is only one, so it's B. Okay, now there are some specific terms associated with eigenvalues. If any eigenvalue is repeating itself multiple times, we say that its algebraic multiplicity is that. So in this case, the eigenvalue 1 has algebraic multiplicity 3. Okay, and okay, so with algebraic multiplicity we also have geometric multiplicity. Okay, so algebraic multiplicity basically tells us how many times that root is there, so 3 times here, and geometric multiplicity basically tells us how many linearly independent eigenvectors are there corresponding to that eigenvalue. Okay, so in this case the algebraic multiplicity is 3 and the geometric multiplicity is 1. Okay, because there is only one linearly independent eigenvector, and the difference between the two, algebraic multiplicity and the geometric multiplicity, is termed as the defect. Okay, it's not AM, that is arithmetic mean, geometric mean, but algebraic multiplicity and geometric multiplicity. So sometimes they might also ask you the following question: what is the defect corresponding to the eigenvalue 1? So the defect is basically the difference between the two. So in this case that defect is 2. Okay, and note that geometric multiplicity can never be greater than algebraic multiplicity. It can at the most be equal to the algebraic multiplicity, very much like arithmetic mean is always greater than or equal to geometric mean. Okay, so this was question number 1. Let's now go to question 2. Question number 2 is very simple. It is actually a 12th standard level question. Let L be the limit of sine squared 2x upon x minus pi by 2 squared as x tends to pi by 2, then L is equal to -4, 0, 2 and 4. Okay, now you can solve this problem by L'Hospital's rule, but what I have done is I have substituted a value of x which is very close to pi by 2. So I am actually using the approximation, and I know that pi by 2 is not equal to 1.57 because it is an irrational number, so it can never be equal to any decimal number, right? So 1.57 is close to this, so I expect that if I let x to be 1.57 and put it in this function here, then I will get a value closer to the limit, okay, or very close to the limit. And so L will be approximately equal to sine squared of 2 into 1.57 divided by 1.57 minus pi by 2 squared. And because calculators are allowed, you can very easily find these with the sine of this angle, and note that this angle is in radians. Okay, so if you evaluate it, it turns out to be 3.999, and hence the correct option is D. Okay, a very simple question. You can solve this problem by L'Hospital's rule or by using the formula sine theta by theta's limit is 0 as is 1 as theta tends to 0, but then for that you are required to make a lot of adjustments. So this will give you the answer fairly quickly. Let's now solve question number 3, which is based on the Laurent expansion of complex variable functions. So we are given a function f of z which is 1 upon 1 minus z squared, and we have been asked to determine the coefficient of 1 upon z minus 1 in the Laurent expansion of f of z about z equal to 1, and the options are -1, -1 upon 2, 1 upon 2 and 1. Okay, now unlike the Taylor series or the Maclaurin series, we don't have a ready-made formula, and even if we have, that formula is very much complicated. So what I have done is, I know that this is a 1 mark question, so it should be solvable in fairly less amount of time. So I have tried to split it. I have tried to split the given function into partial fractions. Okay, so clearly the factors of 1 minus z squared are 1 plus z into 1 minus z, and if you split it into partial fractions, okay, something upon 1 plus z plus something upon 1 minus z, if you determine those, then it turns out that both of them are 1 upon 2 and 1 upon 2 respectively. You can check it. Okay, so if I take the LCM and add now, okay, what will I get? It's 1 upon 2 outside. In the numerator we will have 1 minus z plus 1 plus z, and in the denominator it is 1 plus z into 1 minus z, which is 1 minus z squared, and plus z minus z will get cancelled, and 1 plus 1 is 2, and that 2 will cancel this 2. So this partial fraction split is right. Okay, now as far as the second term is concerned, we already have 1 minus z. Okay, and if I change it to z minus 1, then this 2 will become negative, and we will therefore get negative 1 upon 2 into z minus 1. So we actually see that term here, negative 1 upon 2. Okay, so we have already got our answer, that the coefficient of 1 upon z minus 1 in the Laurent expansion of f of z about z equal to 1 is negative 1 upon 2. But what I have done is I have gone one step ahead, and kind of verified that this particular term here does not have 1 upon z minus 1 in its Laurent expansion. Okay, now in order to check whether it has or it doesn't have, we have to proceed like this. Firstly, I will rewrite 1 upon 1 plus z as 1 upon 2 plus z minus 1. Okay, and then I have taken 2 common from both the terms, and this change is deliberate. Okay, we have to take 2 common because now it takes the form 1 upon 1 plus z minus 1 upon 2. Okay, and now I can use the sum to infinity of a geometric progression formula, okay, which tells me that if it is 1 upon 1 minus r, then the expansion is 1 of, okay, let's take plus because here we have plus, so it is 1 minus r plus r squared minus r cubed and so on, isn't it? So it's because of this I had to rewrite 1 upon 1 plus z in this particular form. And secondly, we wanted the Laurent expansion about 1, so this is important. We could have directly used the formula 1 upon 1 plus r here, but then we could have, I mean, in that case we had obtained, we would have obtained the Maclaurin or the power series expansion in terms of z, but here we want it in terms of z minus 1. Okay, alright, so with r being z minus 1 upon 2, it will now become 1 upon 2, which is already there, into bracket 1 minus z minus 1 upon 2 plus z minus 1 upon 2 bracket squared and so on. And by doing this, what we have ensured is, we have ensured that the Laurent expansion of 1 upon 1 plus z doesn't have 1 upon z minus 1 in it, or it doesn't have any negative power of z minus 1. Alright, so that gives me the answer as negative 1 upon 2, and hence it is option B. And the coefficient of 1 upon z minus 1 and the Laurent expansion of this function has a special name. We call it the residue. So you could have solved the problem the other way as well by directly finding the residue of f of z at z equal to 1. Okay, so question number 3, option B. Let's now go to question number 4. Question number 4 is based on partial differential equations, and it is specifically a wave equation, as you can see here. Let ux comma t be the solution of the initial value problem. Dabba 2u by dabba t squared is equal to 9 into dabba 2u by dabba x squared t greater than 0, negative infinity less than x less than infinity, u of x comma 0 is equal to x plus 5, partial u by partial t, add x comma 0 is 0, then u of 2 comma 2s, and we have 4 options. Now there isn't much information given here. We are only given 2 different conditions, and both of them happen to be the initial conditions, right? U of x comma 0 is x plus 5, and dabba u by dabba t at x comma 0 is equal to 0. Okay, so what I have done is, I have assumed that the solution of this differential equation is in the variables separable form. That is, I can write u as f of x into g of t. Okay, and because I know that u of x comma 0 is equal to x plus 5, this has implications, and that implication is u of x comma 0 is x plus 5, meaning I can now write u of x comma t as x plus 5 into g of t, and I can say that g of 0 is equal to 1. Okay, now I have made another assumption here, and I have assumed that g of t is a linear function of t again, which is equal to at plus p. Okay, now if g of t is a into t plus b, and we have got g of 0 equal to 1, right? So if I let t to be 0, okay, then I will get the value of b to be 1. Okay, and therefore g of t is now at plus 1. Okay, now from g of t, what I can get is I can actually get an expression for da by u by da by t, because for da by u by da by t, x plus 5 will be there as it is, because now f of x is actually x plus 5, okay, into da by u by da by t being a linear function, well, g of t being a linear function, its partial derivative with respect to t will be a, correct? And what they are saying is partial u with respect to t at t equal to 0 is 0. Okay, so what does this mean? This means that x plus 5 is definitely not going to be 0, and therefore a is equal to 0. Okay, so we have made some simplifications here, and because a is equal to 0 and b is equal to 1, we have got g of t to be equal to 1 for all values of t. Okay, alright. So now we have obtained the general solution, u of x comma t as x plus 5 equal into 1, and note that this particular function satisfies everything that is there in the that is given in the problem. Okay, u of x comma 0 is equal to x plus 5, yes it is. Partial u by partial t is equal to 0 for all values of x at t equal to 0, yes it is. Okay, so we are now being asked to find u of 2 comma 2. Well, of course our solution satisfies the given differential equation too. Okay, yes, they are saying the solution, so our solution is right. Okay, yes, so u of 2 comma 2, 2 plus 5 is 7, this is always 1, so the correct option is A. So question 4, option A. We will now solve question number 5, which is a probability question. Two students take a test containing of 5 true or false questions. To pass the test, the students have to answer at least 3 questions correctly. Both of them know the correct answers to two questions and guess the answers to the remaining 3. So the probability will come into play here. They are guessing the answers to the remaining 3. The probability that only one student passes the test is equal to 6 by 32, 7 by 32, 1 upon 4 and 3 by 4. Okay. So the test consists of or comprises of 5 questions, and they are true or false questions, and in order to pass the examination they should answer at least 3 correctly, because that is given in the question. Okay, and in addition to this, they are also saying that both of them know correct answers to 2 questions. Okay, so 2 of them out of 5 questions that they are going to answer will always be correct. Okay, and now we need to find that the probability that only one student passes. Okay, so we will find the probability that the first student passes the examination and the second student fails. Okay, now it is very clear to understand here that the student S2 is going to fail whenever he is unable to answer those 3 questions for which he doesn't know the answer, he or she doesn't know the answer. Okay, now the 3 possibilities under which S1 can pass is he will answer all 3 correctly, or he will answer 2 of them correctly and will mark the last one incorrect, or because at least 3 should be correct, even if he marks or even if he guesses one answer correctly and the other 2 go wrong, that's fine. Okay, all right. So and again, this is a true or false thing, so this is basically a Bernoulli trial. Okay, and in a guess we are not favoring the true output or the false output of the result, so both are equiprobable. So in the binomial terminology, P and Q both are equal to 1 upon 2. Okay, so the probability that S1 passes is equal to, but S2 fails, is 3C3 into 1 upon 2 raised to 3 into 1 upon 2 raised to 0 plus 3C2 into 1 upon 2 squared into 1 upon 2 raised to 1 plus 3C1 into 1 upon 2 into 1 upon 2 squared into the whole bracket into, now this is the probability that S2 fails with this part. So the probability that S2 fails is he fails to guess the answers to all the 3 questions for which he doesn't know the answers. So 3c0 into 1 upon 2 raised to 0 into 1 upon 2 raised to 3. Okay, alright, so we can simplify this now. 3c3 is 1, 3c2 is 3, and so is 3c1. Everywhere you have a cube of 1 upon 2, so you can take it outside. And then 3c0 is 1, this is also 1, and 1 upon 2 cubed is 1 upon 8. So it will be 3 plus 3, 6, 6 plus 1, 7, 7 divided by 64. Yeah, okay, so this is 7 by 64, sorry. So this is 7 by 64. Okay, but the thing is, we can also have the other possibility where S1 fails but S2 passes. Okay, because we want only one of the students to pass. So we must multiply our answer by 2 in order to get the required probability, which is 7 upon 32. Okay. Yeah, so the required probability is 2 times 7 upon 64 because we want, well, we are not giving any preference to S1 or the first student. Even if one of the student passes, we are okay or we are happy with that. So the answer is 7 upon 32. Question number 6, numerical methods question. The equation g of x equal to x is solved by Newton-Raphson method, starting with an initial approximation x naught near the simple root alpha. If xn plus 1 is the approximation to alpha at the n plus 1th iteration, then xn plus 1 is equal to. Okay, now here the method that we use is extremely important. Okay, because we have seen some other methods as well which are capable of solving equations of the kind g of x equal to x. Okay, if you look at option C, you will immediately understand which method I am talking about. Okay, alright, but the problem wants us to solve it by the Newton-Raphson method, so we will bring the given equation in the form f of x equal to 0. Okay, so let's pick it as g of x minus x, because if g of x becomes equal to x, it is as good as saying the difference between them becomes equal to 0. Okay, and now we go back to the formula for the iteration of iteration in the Newton-Raphson method. Okay, so what is the formula? The formula is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Okay, I hope all of you remember this formula, and this time in our case f of x is g of x minus x. Let us substitute it to get the answer. Okay, so xn plus 1 will be equal to xn minus g of xn minus xn upon g dash of xn minus 1. Okay, so this g dash of xn minus 1, let us keep it in the denominator. Okay, and let us take this xn here. So it will be xn into g dash of xn minus xn minus g of xn plus xn. So that will lead to cancellation of these two, and there we will get our answer as xn into g prime of xn or g dash of xn minus g of xn divided by g dash of xn minus 1. You have to pick the option very carefully. Okay, xn into g dash of xn minus g of xn upon g dash of xn minus 1. So it is option B. Why not option A? Yes, it is not option A because in option A the denominator has opposite sign to that of our denominator. Okay, alright. So in this video we have solved the first 6 questions, all 1 mark questions from 2007. In the next video we will resume our solutions and we will be solving the 2 marks questions. Thank you for watching and encouraging me to upload more and more videos. All the best for your preparations. If you have any doubts or any queries, you can ask me anytime. My email ID is mentioned in the video description. Thank you.